Hi, class, Dr. Lindner. Let's continue with the brain. And what I want to focus on now is a little bit more on the brain and some of the important landmarks and some of the important functions in terms of lateralization of left and right brain. So remember, think of the brain as like a bunch of hills and valleys like this, right? So the hills are gyri, and then the valleys are the sulcus, right? So you remember pre-central gyrus, post-central gyrus, those were the hills, okay? So we're going to be talking about some fissures in a second. A big one is called the longitudinal fissure, and that's going to separate your left from your right cerebral hemispheres. Now, let's not confuse cerebral. Cerebral relates to cerebrum. When you're talking about the cerebellum, we will say cerebellar hemispheres. So cerebral relates to cerebrum, cerebellar hemispheres relates to the cerebellum. So even though the left and right hemispheres, we have this separating landmark called the longitudinal fissure, both left and right brains are connected through white matter, these axons, called the corpus callosum. It's a band of white matter, a band of axons going left to right hemisphere. So when we look at a bird's eye view of the brain, this is the bird's eye view looking down, this is looking at it from the side, you can see that fluorescent green, that's the longitudinal fissure. That's going to separate the left from the right cerebral hemispheres. Now, if you look at the fluorescent yellow, that's the central sulcus that separates your precentral from your postcentral gyrus. If we look at it down here, it's going to be right in this region. That's the central sulcus here, right? And again, that's going to separate your precentral from the postcentral gyrus. Between the parietal lobe and the occipital lobe is the parieto-occipital sulcus. That's going to go right there. Now, in terms of lateralization, right, even though we have this fissure right here, like the longitudinal fissure that separates the two, there's going to be corpus callosum that connects the left and right hemispheres together. So there's, even though we say someone may be more left-brained or right-brained, they're talking to each other, okay? But this concept of hemispheric lateralization, we know that the left brain may be more biased in terms of dealing with language, numbers, logic, understanding, sign language, all left-brained. And right brain is more artistic. It's more music and art. And do you think this picture goes good on this wall here? Should I move the couch over there? Does this striped shirt go with these pants, right? Space and pattern perception. A little baby recognizing its mother or father, really right-brained activity. Being able to differentiate a smile from a frown, the emotional content and facial expressions, generating emotional content to the language. So rather than me speaking and teaching like this, if I'm teaching all about the brain in this type of manner without any emotional affect and changing my tone, you would know I am more left brain. But because I can add this emotional content to my language, it means that I'm more right brained. Okay. But again, remember the corpus callosum is going to be the communication between both of these together. Because the language, spoken and written language, is controlled mostly on the left side, when someone has a stroke or lack of blood flow to the left side of the brain, it can produce something called aphasia, which is the inability to speak. Okay, and typically on the left side, there's an area called Broca's area, which is area number 44, that could be damaged that affects that. Okay, so that's a little bit about hemispheric lateralization, understanding what the left side does predominantly, what the right side, but because of that corpus callosum, they are communicating with each other left to right.